So what we're going to do next is we're going to just fix some small issues we have with this effect. So if I look at the object right now, it works great when I move it back and forwards. It's got a few weird things in the bulge, but that's mostly just settings. If I rotate the object, the bulge works to a degree, and then it starts actually spreading out from the side. And that's not what I want. I want the bulge to work even if the object's been rotated, even if I bulge it all the way down to the ground. I don't want it to kind of spread out. So how do I fix that? Well, this is due to the raycast. And right now the raycast, if we look at it and frame it, we can see its direction vector is 0, 1, 0. But it's not taking into account the object's rotation. So we need to add that in. So we're going to go to get data, and we're going to get self, of course, because we're working on the object itself, and then explore that. And we're going to take the kinematic global orientation and take the Euler rotation. Now we need to fix it in, feed it in to the direction. Now we can't just feed it straight into direction. It just won't hook in. It's a type mismatch. So we actually need to rotate it, the vector. So we actually look at vector, and we actually see there is a rotate vector effect here, rotate vector under rotation. And what that allows you to take a vector and rotate it. So we just in here type the vector you want to start with, and that was the same vector I had in the raycast, 0, 1, 0, 1 in the y. We bring the rotate vector in here, and then hook this in to the direction. Now, it may look like something went terribly wrong here. It didn't. All it is an invert here. It's actually been inverted, so we need to invert it back so it's the right way, because we can't just take the standard rotation. We kind of get a double direction here. So just take an invert node. Whenever you see something go inside out and upside down, stick an invert in and see if it fixes it. If it doesn't, may have to do a bit more work. But let's put the invert in. I could have just dragged and dropped that straight in, actually. Let's do that. It's easy to forget you can just drag and drop onto the actual lines. There it goes, and it's fixed. So just taking the object's Euler rotation, inverting it, using the rotate vector, we actually get the result we wanted. And now, regardless how much we rotate it, it's not going to give you any unpredictable or weird results. And that's one of the fixes I wanted to show you. And we'll go ahead and do some cleanup and maybe add a few more features to this until we turn to a final compound and a tool we can use ourselves. I've taken a little bit of this and organized the ice tree a bit more just to make it easier for the next step.